Hey everyone, welcome back to our weekly game dev live stream. I'm Geoff from Lost Decade Games, and today I'm going to be working on a little map generation. As you can see, I've got my cool green screen effect going on here. That's kind of new. But let's just jump right into it. Let's see. Got to remember where I left off last night as I was working on some of this map generation code. Hopefully the audio is a little better on this stream as well. If not, we'll try and fix that too. First off, let's just take a look at what I'm currently working with. Oh, mute that. Ooh, we have a big blank. Big blank area here. It's not really what we wanted. It's fun of procedural generation sometimes. So I've been trying a few different map generation techniques. Again, we are using a Unity library called SpriteTile, which powers all of the tile map stuff that we're using. It's a pretty interesting little package, and it allows you to do completely hand-curated maps using the tile editor, which we've seen in previous videos, and it also allows you to procedurally generate tile maps using the API. And you can do that in a couple different ways. The first way is, just by, absolutely placing tile values yourself. So you can say, tile 5 is equal to 1 or whatever. The other thing you can do is you can actually piece chunks of maps together into a larger map. So that's actually the technique that I'm using right now. I had some pretty interesting ideas for how to make that do what I wanted it to do. And so I'll kind of just give you a brief tour of how that works. The gist of it is that I wrote this code here that generates a map. And it's really simple right now. I've actually taken a few different stabs at it. And so you can see some commented out versions. But the basic idea is that it starts, it generates a map of so let's say 4x4 in this case, 4x4 rooms. And the rooms are not defined here because this piece of code doesn't really care how big the rooms are in terms of tiles. This really only cares about which rooms are connected to which other rooms. And so it picks a random starting room right now, which is just the center of the map, which, that can be configured or changed depending on how you want the level to generate. It creates that room in the starting location, and then it creates what I call miners. And the miners are really just little coordinate holders that move around the map and kind of burrow out new rooms as they go. And so we just create one miner for now, just to keep it simple. And then we have a loop that says while there are at least one miner, we take that miner and we look for all the empty neighbor cells adjacent to that miner. And if there aren't any empty cells, then we kill that miner off because he can't go anywhere. But if there are, we just choose a random cell adjacent to the miner and we kind of burrow into that room. And then we make that the miner's new location. And then rinse repeat. So the effect is that, let's say the miner starts in the center of the room and there's, all 4 adjacent rooms to him are empty. He just picks one randomly, let's say to the right, and he moves there. And then he picks, and then the cycle continues again, except for this time, the room to the left of him, which he just left, is now not empty. So now he only has a choice of the 3. Up, down, and right again. Anyways, and so that kind of just creates a very simple map. It has some problems which we need to solve at some point. So the things would be like what to do about what I call orphan rooms, which are rooms that, if you have a 4x4 grid and you trace a path through it, there's possibilities that you'll get a room in the corner that didn't get hit or something like that, just because of the way that the random rooms get chosen. So usually what I do is I go through all the orphan rooms and I just connect them randomly to any one of their neighbors. And so you get like these little dead ends. So I might do that at some point during the stream. And yeah, it's kind of just a simplistic view of creating rooms that connect to each other. I've got some really kind of gross code right here that connects the rooms to each other, but essentially what it is like a bit mask. And so there's a on the room, simple room data structure itself, it just has an int for exits. And when we connect rooms to each other, we just have this little gross if statement here that basically does some bitwise operations. And so that later on we use that to know which directions we should have exits on the room from. And so we use it in kind of like a going around the room starting to north. So the northmost exit is 1, and then the eastern exit is 2, southern exit is 4, and then the western exit is 8. And so you can bitwise OR those values together. And so, for example, if you have a exit on the north and the south, that would be a 1 and a 4, which is 5. And so that's a unique value that we can use to basically determine which room templates we're going to use to put a room there. So once we have that, basically what we do is this call right here, map generator.generate, is what creates that map with the rooms connected to each other. And then this is where we define how big the rooms themselves are. And so for now, we just have like a static height of 21 by 15, which I just picked because I played around with it a little bit and it looked good in my tests. So, but that could always change. Then we use the SpriteTile API to create a new level using the width and height that we just determined. Then we loop through all of the rooms. So we do kind of a double nested for statement here that loops over the X and Y axes of the rooms. And what we do is we grab a reference to that room, and then we, right here is kind of like the hard-coded portion where we determine which room template to use. And these room templates are actually SpriteTile levels that I've created that are just very small chunks of map. And so let's go take a look at that real quick. So if we go to the SpriteTile editor, you can see like here's one. So this would be the 12 room, and the 12 room is you get an 8 on the western side, and then you got a 4 on the southern side. And so 8 plus 4 is 12. But we have a whole bunch of other ones, like we have a 4, which would just be the southern exit, and a 3, which would be the top and the right northern and eastern exits. And I've tried to intentionally kept all of these rooms pretty simple, but we could really do all kinds of crazy stuff. So for example, I have a couple of these rooms. Like this is it's got exits on all sides, so it's a 15. And there's a couple different variations of this. It's like a 15A, B, and C, and a D. And so right now we're not using all the variations because in the code we're just hard coding it to use the A version. But the idea here is that, we could take this room exits value and we could append random A, B, C, D, whatever to it, and get template randomization that way as well. But just for the immediate use case, we're keeping it simple by just using that singular template. However, one thing I did want to improve upon from a Wizard's Lizard. This is a very similar way that a Wizard's Lizard generates levels, with the exception that the templates aren't as hand-curated. Sometimes they are, and sometimes they're more programmatically created. Like, for example, we could take a room that has a dynamic width and height and put blocks in the corner, for example. But one thing that I wanted to improve upon was like the idea that if you have, let's say, this room, this number 8, and you want to put some interesting geometry here in the middle, right? You want to have like a big island in the center, or you want to have, kind of like blocks along the top and the bottom, or, a square, or who knows, whatever you want to have in the middle, right? You don't want to have to like do that for every single version, right? You don't want to have, let's say you wanted to have like a C where it starts here in this corner. I'll just draw like a quick idea. Like, I won't flesh out all the walls, but let's say you want to make a room that looks kind of like that. You don't want to then have to go and make this C again for the room that has a northern exit instead, right? So what I did is I further broke this down into what I'm calling inserts. We're not going to save that. And so inserts are just interiors of rooms. So here's one that's really nothing. It's just got some hints, some triggers in the corners for lights. This will just be a completely empty room. But there's other versions like this one, which has 2 kind of columns in the middle. And it's also got these number 3 triggers here for lights. And we've got kind of like this N or upside down U. And the U itself. And then kind of a bigger island. And then this little C one. And so we could make whatever version of these we wanted to. And then use those. And so you can kind of see how that works in practice. There are no lights in this room, so it's a little dark. Maybe I should put that in there. So let's kind of travel around our map. I turned off collision for the moment being because it's easier to walk around the map. So you can see like this room right here, it's got an exit on the left, and that's it. And if you remember, our template that had the exit on the left was just this big empty room, but we've taken one of those room interiors and just plopped it in there randomly. So it's got that big island. And so this is also a room that has a northern and an western exit, and it randomly got chosen for the one that has the 2 columns in the middle. And so the end result is that we only have to define these room interiors once, because you can see the same 2-column interior is on a room with a eastern exit and a southern exit, but not the western or northern. So that's kind of the gist. Matt loves the green screen. It's amazing. I think it's pretty fun too. Although it's still a work in progress, obviously. So basically the ways that we want to improve upon this are to, 1, not hard code this A template so much, because we do want to have some other room templates that aren't necessarily the same, like the big empty rooms. So kind of like this 15, where we have several different versions, where we have one version that's just a big empty room, and then some other ones that are not. So like we're already kind of doing that with like the 5, I think. And so see, the 5 is just this hallway. But really 5A, I kind of decided that I think that the A templates should be kind of more generic, and then I'll start using the other variations to spice it up a little bit. So we'll go through actually, and we'll just make this a kind of more generic square room. I guess there's a fill. I can use that too. That's pretty fun. That was a little easier. And then let's put the corners here. And we need to fix this guy. And then we also need to put down our walls, because we have this interesting 3 tile high wall perspective. And then Matt just made some kind of edge walls, which make these walls that border the hallways a little bit more pronounced. Got a little black border right there, which is nice. So we'll save that as 5A. Then we'll turn on triggers. And so we've got 2 lamp triggers, which are 3s. So I'm going to take those out for the moment, actually. I'm going to put a 1. And the way that I'm using the 1 trigger right now is that the 1 trigger is basically just says put a room insert here, starting here. The reason it's in the lower left is because SpriteTile and Unity in general, they have a little bit of different coordinate system than you would expect maybe from a tile map. And so you can kind of see, actually, if you look in the lower left-hand corner of the SpriteTile window, you can see that it shows you the X and Y values. And the X, as you would expect, increases in value as you go to the right. But the Y starts at 0 in the lower left and increases in value as you go up. And that's because the way that SpriteTile renders the level, it kind of starts in the lower left too. Like the lower left is the origin and Y goes up. And I think that's partly just because it's the way that Unity does it. So if you're thinking about the Unity coordinate system, 0, 0 is the center of the screen. Y goes up, and negative Y goes down. Negative X goes left, and positive X goes right. So it's just a little bit of a different thinking. And so, you know, my first inclination was to put the 1 trigger up in the upper left because that's what made sense in my head, but really it goes down here because that's where we tell SpriteTile to insert the chunk of map data. So anyways, we're going to put that 1 there. And I think, let's just make sure that all the rest of our templates are kind of generic. This is a different, a number 1. So we should even this one out too. I find SpriteTile to be a pretty fun tool to use. It can certainly, certainly has a little bit of clunkiness with regards to how the tools work. Oops. But it does the job pretty well. I think especially if you're working on things that are maybe more procedurally generated, I think that's one of the reasons that I like SpriteTile over some of the other solutions I looked at, was that I knew from the get-go that I wanted the ability to generate maps procedurally. And this one has an API, and it's maybe not the best API, but it's pretty well documented. There's a nice set of PDFs that the author provides that go through all the API calls, exactly what they do, all the data structures, that kind of stuff. So we'll save that guy, and we'll turn on triggers. And then we'll put also a number 1 down here. Oops, that's not what I wanted to do. Let's go back and, there we go. And then the number 2, we're going to fix this guy. A lot of these things I was kind of just messing around with, creating various different rooms. But once I kind of settled on an idea for how I wanted these room templates to work, I want to start with just some generic rooms that I can vary really easily using that kind of room insert system that I was just talking about. So we're just going to get rid of all those and save that as a 2, and obviously the 2 corresponds to the fact that there's an exit on the right-hand side. So open up 3, which is top, and then right, open up 4, that looks good. 5, we just refactored that one. 6, we don't have a 7, haven't needed it yet. 8, 9, 10. So this is another one I was kind of messing with just because it's a little more interesting, but we're going to make it a little boring for the moment. I'll go through, and really what we want to do is just make sure that we keep those exits on the left and the right. that. I don't know, I have an immense amount of fun making maps. It's kind of fun to just put tiles down, I think. Oopsie. Except when you go way out of bounds like that. You got to come back and redo it. SpriteTile also has some other interesting features where you can put down randomized tile sets. I'm not using those right now, but for example, with this tile set, you can see that there's a few different floor tiles. And so every time we put one down, it kind of randomizes. You can see that the pattern kind of changes up as I do that. This tile set that we're working with right now doesn't actually have any randomized tiles, so we're not using that particular feature at the moment, but it exists. It also has a nice handy terrain feature where you can create some terrain and where it'll auto fill in the edges. And that's actually pretty cool, but it doesn't really work for us in this particular context because we have this kind of non-standard idea of the perspective. If we were doing more of a traditional tile map where the top edge was just one tile wide, then that would probably work a lot better for us, but we're not, so it doesn't. Okay, so we'll go back to our triggers. We'll remove those. And then we'll put our 1 down in that corner so that it'll fill it up with a random insert. And that was what? That was 10. So I think all the rest of them, yep, 12, and then 15A, yep, okay. So we got all those. And so now we have basically all these square rooms that are connected together. And they all have these random inserts in them. So you can see sometimes they have the big island, sometimes they have the U. And these inserts can appear in any exit configuration, which is kind of cool. And the room templates themselves are the ones that would contain the hints for like the lights and stuff. So just to kind of give you a better idea how that works. If I open up the inserts, so this big blank one, if I turn on triggers, you can see that it's got number 3 triggers in each of the corners, and so this is where the lights would go in a completely empty room. And then, for this number 2 template, the lights go down here in these little corners. And so what we could do is we could also just put like a number 3 here and a number 3 here. Oops, that'll be number 4. Number 3, and save that. And then if we encountered, so there are some zeros, essentially, that cause those big gray blocks. So there's a lot of bugs and edge cases we have to work out with this method. But there we go. See, now you can see that there are lights in the top corners of those kind of middle island things. So that's all looking pretty good. This is a big area where there's a 0. So this is an area, this is basically a room on the map, which is empty. There is no room data there because the minor algorithm that we wrote earlier, or that I wrote earlier, I guess I didn't write it on stream, it didn't put a room there because, random happenstance. So that's something we want to go back and fix at some point so that we can put rooms in there. But first, I think I'm going to, check in on chat. Oh, hey, I got Richard Fulmer here, one of my friends from World of Warcraft. Yeah, so the purple squares in the middle of the rooms are triggers, and so SpriteTile is pretty basic, and so you can Basically what I'm doing is I'm hitting the T key, or you can also click this trigger checkbox right here in the bottom, and that will turn triggers on and off. And you can set triggers on tiles by holding the Alt key and clicking on it, and then you'll get this little pop-up menu right here, and you can edit the number. And so these triggers are completely freeform. Again, the UI is not the best, but it's one of those things that once you understand how it works, it's pretty quick. There's a lot of hotkeys. It's certainly not very beginner friendly, but once you figure out how it all works, it's pretty simple. The basic idea is that you can just assign a number to a tile. So not only can you put a value there, so you can see that these are kind of transparent, so they can have a floor or a wall or whatever in that slot, and then they can also have just some random number attached to them. And then the random number is what I use to place objects. So for how that looks in the code, basically, we can go into this function I wrote called place objects. And really all this does is it takes a string array of prefab names, which is just paths to prefabs that exist in Unity, and then a trigger number, and then some other data like limit and density, but that's not important right now. What's important is that SpriteTile exposes this API call called get trigger positions. And so what you can do is you can just get all of the triggers from a map of a certain number. So for example, here we would say, find all the triggers of number 3, and then we're going to place a lamp object there. And so we're using a little game object manager here to spawn an instance of a lamp. And it kind of goes through randomly. And so the limit and the density variables kind of control how many of those get spawned. And so that data exists here in our custom level XML. And so, for example, here, you see this object trigger equals 3. And so whenever I encounter this, I say, okay, find all triggers that have a 3, and then put one of these random prefabs here. And in this case, it's only one prefab. It's a lamp. But we could easily just add, another line here that says like props, houseplants, I think is another prefab that Matt made. And so now if we load up our room, anything that was a 3 could be either a lamp or a houseplant. Or there we go. Okay, that was going to make a liar out of me, but it didn't. So you can see in this map, there's a 3 in each of these corners, and one of them turned out to be a plant, and one of them turned out to be a lamp. A lamp and a plant. And in this case, there are 2 plants. So that's kind of how that works. The other things that I have to control it would be like limit. So I could say limit is equal to some hard number like 5, and so it only, no matter how many triggers there are, it would only spawn 4. I have another parameter called density. So I could say density is like 0.5. And then that would make it so, let's say there are 24 triggers, 12 of them would be filled with some kind of prefab. For now, we just want 3s to be lights, because whatever. And then this other data down here, if you remember from previous sessions, was about creating warp zones and stuff and linking levels together. That stuff has kind of been bulldozed for the moment. I mean, it still kind of exists in the code, but I don't have it kind of hooked up at the moment because I'm working on other facets. Something else I was also working on, which this may change, but I was calling them mechanisms. Mechanisms are basically object pairings that are linked together. And so in this particular example, it was a pressure plate and a block toggle, which was really just a impassable block that could be raised up and down by clicking a button. I think that's going to be handled in a different manner, though, going forward. A lot of this project is basically just a big playground for me at the moment to kind of figure out Unity and test some ideas I have with regards to generation and stuff for these maps. All right, Dan, thank you for stopping by. It's always good to see people hang out. Let's see who we've got in the chat. Oh, nice. So that's kind of the half-an-hour description of what I've been working on in the last week and how I'm kind of approaching level generation. I was trying previously I was trying an approach where I was creating entire maps in SpriteTile, entire levels, and so that would be like, let's see, where did I put those? Data, levels, maps. So if you remember from previous streams, I was working on maps like this where they were kind of entire levels created in SpriteTile with, you know, all these different things all over the place. And that's okay, but I don't know. It really didn't give me the effect that I wanted with the procedural level generation. So I kind of moved back to more of like the room-based approach that we used in the Wizard's Lizard. So I think the first thing I want to do today is vary up these templates so that we're not just always using the same version. So this thing is like a little bit of deprecated code right here. That's when I was testing. But here's where we want to actually say, you know, which variations exist for a particular set of exits. So I started working on that. I think I'm going to use a dictionary object for that. And this will probably be something that I want to put into a config file somewhere, maybe per level. It seems like something that I would want to control on a per level basis, perhaps. For now, I won't, but just kind of thinking about it in general, it seems like something where you would want to say, for this particular level, you can use A, B's, and C's. But for another level, you only want to use X, Y's, and Z's for a particular exit pattern. I don't know. Flexibility is always good. But for now, we're going to do this. C# has a little bit more of a verbose initialization syntax than, like, say, JavaScript, which I'm used to. So, for example, what we're doing is creating essentially a hash table. Well, it's not really a hash table because hash tables exist in C#, but a dictionary is more of like a typed hash table where we have an integer as the key and then an array of strings as the value here. And so what we're going to do here, I think, is just create this. And so the first value is going to be, let's say, 1. And then it's going to be a new string array, which we're also going to initialize right away as like A, B, I think. So let's make sure we got all our brackets in the right place. Let's see if Unity complains about this. Oh, it does. So this is where we're going to have to look up C# directly initialization. So this is kind of what I was going for here, is this kind of a thing, but maybe it's not going to work with arrays, string arrays. Let's see what the errors actually are. Unexpected symbol equals. I guess it doesn't like that. Maybe we could just do it this way and start. We can just say, oh, actually, I know what I did wrong. I forgot to give this a name. All this verbose syntax, and I forgot to actually say what the variable is called. So we're just going to call this templates for now. Let's see if it likes that a little better. Yes, it does. Great. So we have a bunch of warnings and some debug stuff, which we're not going to worry about at the moment because I don't care. So it looks like it went through. So let's just run the program, make sure it doesn't crap out on us. Great. And so let's start with 15, because 15 we know we have an A, B, a C, and a D. And just to make sure this code is working correctly, we're going to come down in here, and we'll say int exits equals room dot exits, although for now we're going to override that to be 15. And then what we're going to want to do is we're going to say chunk names. I guess this would be string array chunk names is equal to templates exits. So it'll be 15 theoretically. And then we'll say string chunk name is equal to the exits value dot toString plus a random string from this array of chunk names. And then we'll just debug log that to make sure that looks like what we want. So what we should see in the debug log is a bunch of like 15 A, B, C, or D's. Yep. So 15D, 15C, 15D, etc., etc. Let's see. Let's get rid of that. So we've still got some of these kind of like empty rooms, but that's okay. So now every room in the map should be the 15 template, which is exits on all sides. And so it should all connect together pretty nicely, but you know, obviously the bad part is that one, they're all connected to each other, which doesn't make for a very interesting maze. And two, they're all connected to the edges of the map, which is also something we don't want, because then it looks like you can just walk off the map, which you can. And so now I'm off in the ether of the map. And if collision was turned on, you know, I could be outside the walls, unable to get back in. So that's working pretty well. So now we just need to go through and fill this data with the actual room templates that we have. So, you know, for example, actually I can just copy this whole line completely. And so like for template number 1, we're only going to have an A at the moment. I think I want spaces there. So we'll add a bunch of these. And we'll go back and say, you know, 2, 3, 4, 5, 6, 8. Oops, 8, 9, 10. And then we also have a 12 at the moment. And I think that none of those have any variations at the moment. So let's just look. Data, rooms, 1, 2, 3. So these all have A. Yeah. So now what we can do is we can go into 1 and start creating some variation. And so instead of, you know, just this guy, we can go make more of like a round room, for example. So let's see what that would look like. Maybe let's kind of extend this thing kind of like by two at a time. And then we'll do the same thing from here. We want it to kind of come up, let's see, so like right about here. And then we'll just kind of take out these corners for the moment. The maps are much harder to visualize when you're creating them with this three tile high wall, especially since like the reverse isn't true on the bottom. But I think I'm getting pretty good at figuring out what it's supposed to look like. Go put all those in there. And so I'm going to say this is 2B. Oops, sorry. No. 1B. Because it's a 1, it has an exit at the top. So put those toppers there. And then these guys here. And then those corners. These corners. And then we can just go erase all these guys. There we go. Now we have a kind of round descent room, although I need to go back and do these guys. Make these walls look a little more defined. Perfect. And then sometimes I just like to turn on the collision map real quick and just make sure that the collision areas look like they're supposed to, which they usually do because all the collision data is kind of stored per tile, so it just kind of works. And then I will go in and add a couple triggers for lights here. There we go. Oh, remove that guy from the corner. And then maybe we'll put a light right there just for grins. And so now we have an alternate template of B for the number 1. And what we'll do is we'll just force this to be 1 every time, just so we can kind of see what it looks like, make sure that it does what we want it to do. So you can see, yep, this is a 1. This is a 1 room right here because it's got the exit at the top. And the things aren't going to line up right because we're using, we're hard coding the exits, not looking at them based on what the map says they should be. So this is another number 1A, but this one has the upside down U in the middle, and where this one just has the empty middle. And then over here to the right, we've got a 1B, and this one doesn't utilize those kind of randomized interiors. We kind of gave it some static light layouts, and that looks to be working pretty well. So in a kind of real world scenario, anytime that there was a number 1 value on the map, you would be getting randomly either this kind of round room with these 3 lights in it, or this big square room with another random component of the interior. So we can go take out our hard-coded exit value and make sure that's all working. Got some, there we go, some missing rooms there, but that's okay. We'll go back and fix that at some point. So that's looking like all the stuff is connected in the right way. We determined that the randomized rooms for the number 1 template were working correctly, but we may not, see those. 1, because we may not even have a 1 in this map, and 2, if we did have a number 1 in the map, it could be randomized to the square room or not. So who knows what we would see there. For now, we're not really seeing a whole lot of dead ends. There's probably only 2 dead ends per map, and so we're seeing a lot more of the templates that have like multiple exits, or at least 2, right? The way that the map is generating right now, that most tiles or most rooms are going to have an entrance and an exit, because the miner would say start in this room, and he would pick south, and so he'd tunnel into this room, and then he'd pick this next room, and so we tunnel that way, and so the room that he just left would end up with 2 exits. And then he'll go up here, and so on and so forth. And so this one actually only has 1 exit. So this is either where the miner started or where the miner ended, one of the two. And then again, down in the lower left-hand corner, we have these rooms that the miner didn't even touch, which need to be dealt with. Let's check in on chat. Let's see how people are doing. Yeah, rain effects is something I would love to do. The tearing is interesting. It doesn't actually tear in the built version. It has something to do with lighting, which is kind of weird. It has something to do with the pixel lighting, specifically on SpriteTile. The tile seams are really difficult with regards to lighting, I think, for some reason. Because basically all of these tiles are just sprites that SpriteTile is creating. The whole level isn't, there's not one sprite per entire cell. There's basically a collection of sprites the size of the screen, and then SpriteTile kind of like swaps them out as you scroll around the map auto-magically, which is kind of nice because it keeps the performance a little bit in check. But yeah, the tearing is something that doesn't seem to exist as far as I can tell when it's built. So just to check that out. But it is something that didn't even happen until I started adding lighting into the mix. So another reason that I wanted to work on lighting early, you can kind of see lighting as kind of an optimization step, but it's complicated, and it kind of changes the way that we would approach asset creation. One, and also it can have a lot of weird bugs. So it's kind of good to kind of nip those in the bud, I think. So you can see in the built version, there's pretty much no tearing that I can discern. Everything looks really smooth. Also, like, the scrolling is just not as jittery in general, for whatever reason. I think a lot of it just has to do with Unity's kind of preview window. I'm sure that there's a lot more stuff going on, in the built version. So, as long as the built version looks silky smooth like it does, I'm very happy. But yeah, that's the tearing was one thing that I was pretty worried about. But as far as I can tell, it's something that only happens right now within the preview window. So, hello, macaroni. Weather effects is something I've thought a lot about. I definitely want to have some outdoor areas with like rain and stuff, just because that looks pretty awesome. So we can start to clean up some of this code real quick. Get rid of some of that stuff that we don't need. This is the code right here that puts in the random inserts. So it has this list of inserts that I showed you earlier, and then for each of these, it gets all the number 1 triggers on the map, and then for each of them, it loads a chunk of data and uses the SpriteTile API to just insert that into the map, which is kind of nice. This is, so the collision thing is kind of interesting. For whatever reason, it seems that when you load map chunks via the API with SpriteTile, it won't trigger the collision to be active for whatever reason. Oh, I'm like completely outside the map right now. Well, you can see the collision is actually working now. So what I did here was I just went through and I reset the collider bit. Although I was kind of wondering the other day if I could just do that for one specific tile. Like, let's say, comment that out. And then after all this is done, I wonder if I could just say, you know, trigger just maybe the lower left corner. In fact, we can just make that one. Just put that in line. Nope. Errors. Pause. Oh, I see. Yeah. Never mind. No, really? Oh, I guess I'm using it twice in the same scope, and it doesn't apparently like that very much. So we'll call it collide position. Excuse me. Okay, maybe that'll work this time. We'll find out. No. Interesting. So why didn't that work, I think is the question. Because looping through all of the collision in the room seems to work. And the interesting thing about that is that it works for everything, even the newer map blocks that get added in later. Oh man, there's like a whole bunch of missing rooms here. Interesting. Oh, it doesn't work here though. That's weird. Huh. So we have this room right here. So we only have some rooms where the collision is working. Because I could totally just walk through the walls of all these lower rooms. Fascinating. I wonder why that is. But these interior templates, the collision works just fine. And those get added in after that collision triggering code happens. So I'm not exactly sure how that's working. How's my mic this time around? I play with the settings, so hopefully it's a little louder, because the previous streams the mic has been pretty soft. So if anybody can let me know how that sounds, that would be great. Let's see if we can fix these empty rooms. I think I'm going to delete some of this code I was working on earlier that's kind of deprecated now. And we will answer this question, what to do about orphan rooms. And I think what we're going to do about them is we are going to first we got to find them all. And then we're going to connect them to other stuff. So maybe that should be method here. We get a list of all the orphan rooms. Thing is, though, is that I should probably go through and just create all the rooms from the get-go. So maybe I'll create a create rooms function here that will just go through. And so we'll say for int y is equal to 0, y is less than height, plus plus y, and then for int x is equal to 0, x is less than width, plus plus x. We'll say create room xy, and then we'll just change this to be map.create rooms. That way we have a valid room object in every single cell. You know, you could see a scenario where maybe we'd want to actually have completely empty rooms. We could do something interesting there. One, it would just make the map like less square and gritty. So it's certainly an option. But we're not going to do that for now. For now, we're just going to create a room everywhere. And what the byproduct of this actually is going to be is that we're going to get an error here because there's going to be some zeros, potentially. Yep. So it's looking for a 0, and a 0 room means it's not connected to anything. And so just for the purposes of our testing, we'll go define a 0. We'll copy that. Oh, we got some cats fighting. As they do. Get out of here, cats. And let's go into SpriteTile and we'll open up our, that's not it. We want to open up assets, resources, data, rooms. I created this template room that just has exits everywhere. So we're going to save this as 0A, and then we'll just go in and we'll, cats are very unhappy about something. Put some walls there. I don't know if you guys can hear the cats on the stream, but he's talking a whole bunch. There we go. So we'll create, this is our 0 room. It's not connected to anything. Obviously, it's not something we want to have in the final version because that would just not look right. So you can see there it is. Let's turn off our collision again. Untrigger it. So now at least we know right away that what we're looking at, which is that we've got these rooms right here that are completely segregated from the rest of the map. But they actually exist as room objects now, which is good. So now we'll just create a function in here. And we'll say list room, map room. We want a list of map rooms, and we'll call it orphan rooms. And list map room. Orphans equal to new list. One thing I've been wondering about C#, and I don't know enough about it necessarily yet, but I'm wondering if it isn't better to just keep some of these lists around, or like, you know, be able to pass the list by reference into the function as opposed to creating a new list every time we call this function. It's kind of an optimization step though, so I'm not gonna do that right now. One thing I think that we've done is that we've screwed this up a little bit in the sense that this should really be like and rooms and x and y dot exits is equal to 0. Oops, not triple equals, not JavaScript. There we go. So then we'll do another one of our fancy double nested for loops. Everyone's favorite, my favorite for sure. It's probably one of the pieces of code I write the most often when dealing with game maps. Sometimes what I'll do is I will treat the underlying map structure as a single dimension array, where you can map x and y to a kind of single index. That has some weird issues though too, so I think that I've kind of landed on just treating them as a multidimensional array because it's easier to get my head around when I'm trying to think about which map coordinates are where. So basically what we're going to do here is we're going to say if rooms xy dot exits is equal to 0, which means that there are no adjoining rooms. We're going to add, actually we can say map room is equal to room xy. And then we'll say if room.exits is equal to 0, then we'll say orphans.add room. And then we're all done. We'll return that list of orphans. And then here we'll say list map room orphans is equal to map dot orphan rooms. The other way we could do this actually that I hadn't thought about until now, although I guess I thought about it previously, was we could put more miners into the world. So like every time we move into a room, we could spawn a new miner, and so that would kind of like spider out. But I think that's a different, that'll give us a different looking map. We'll have a lot of interconnected rooms kind of near the start. And I don't know if that's necessarily what we want. Ideally, we want to have several different kinds of algorithms that kind of carve out the path around these levels. But for now, we're just going to make one general purpose one that kind of does mostly what we want. So we'll get a list of the orphan rooms, and then we can say for each map room room in orphans. And then what we want to do here is we want to choose a random neighbor and connect. So really what we're going to do is we're just going to create another function here called neighbors. Maybe we'll make this return map rooms as well. I'm still kind of working on how this API should actually work. So it's a little weird, like this empty neighbors thing returns a list of map chords, but this neighbors function returns a list of map rooms. So over time, I'll probably solidify that into something more consistent. So really what we want to do is say, as long as it's a valid room, doesn't matter if it's empty or not, we're going to add it to our list. So let's call this neighbors instead. And And we'll add room neighbor X, neighbor Y. Think that'll work. Maybe, probably, hopefully. So what we'll do here is we'll say this is going to be a list of map rooms again. We'll call it neighbors. And it'll be map dot neighbors for the room that we're in, which we don't know. So this is actually a good reason why these should actually return map chords instead of map rooms. So let's go change that real quick to map chords. X is equal to X and Y is equal to Y, because we still need to look at the room. Return a list of map chords, and then so here we also want to have a list of map chords, and this will be for map chord room chord, or we can just call that chord in orphans. And then we need neighbors chord.x, chord.y. And then what we'll say is we do actually need to get a reference to the room, because the connect room functions takes, oh no, it doesn't, it takes coordinates as well. So really what we want is to also have neighbors return map chords. So I guess we're doing this API cleanup sooner rather than later, because it's just much easier to do it this way. So new map chord, x is equal to x, oops, x is equal to x, and y is equal to y. No, nx and xy in this function, because these are the neighbor offsets, right? Not the actual thing that we're dealing with. So this will be map chord neighbors, whatever, and then we'll say next, we'll say map chord. Well, we're already using next, I think. Maybe it's in a different scope, so we'll find out. Next is equal to rand.choice neighbors. And if I haven't explained it before, rand is this little util library, static library I made that you can pass in a list or an array, and it will just randomly choose an index in that list or array and return it to you. I found that I was doing that quite often in my procedural generation. You know, either choosing one string out of an array for the map templates, or choosing, you know, in this case, a map coordinate out of a list, or what have you. So now we have our orphan coordinate and our next coordinate. So we got all the neighbors that exist as long as they're valid. We'll pick a random one, and then we'll say map.connect rooms chord to next. So theoretically, unless I wrote some bugs, which is quite possible. Yep, I did. Key was not present in the dictionary. Oh, I'm guessing that there was a exit value that didn't exist. So we'll just go back in here and debug.log exits. Because now we've created some scenarios where there could be 3 exits on a given room, which we didn't really have before, and the randomizer didn't catch it this time. But theoretically, there shouldn't be any zeros. It doesn't look like there are. And so we have a 4x4 map. And so every room should be connected to every other room somehow. So we can kind of see, we'll go up, kind of trace a path as if we were walking through the map. And we can see that every room so far has been connected. So this looks like a dead end. So this is either the end or the beginning of the miner. So we can kind of trace that through here. And it comes down. So right now it's kind of like going around the outside of the map, the path. And so then this time we're going to turn inward. This one may not have had any orphan rooms at all, actually. It's possible. So it goes this way. We'll know if there's an orphan room if there's any room that has more than 2 exits, I think. Or if there were an orphan room. Not sure if there was or not. I don't think that there was in this map. Looks like it's pretty much just a single path all the way through to the end, which would be this room. Or the beginning, who knows. We can try it again though and see. There we go, so 13. 13 is a template that we don't have. Let's check on chat real quick. I guess my microphone could be a little louder. Yeah, and the stream happens right now once per week, Mondays, 11:30 a.m. PST. So let's go into SpriteTile, and let's create a 13. So a 13 would be a 12 plus a 1. So if we open up the 12, and we know that the 1 is the northernmost exit, all we need to do is save this as 13A, and then we'll just create a top exit as well. Let's do this. Pretty easy. Although I've done this a lot, so I know. Oops. There we go. So that's our 13. And then the other piece of this puzzle is that we need to go in here and make sure we've got an entry for 13s. And we'll run this some more. And we're also missing an 11. And so an 11 would be a 10 plus a 1. So we'll save that as 11A. And then we'll basically just do the exact same thing. We'll make a northern exit on this room template. And we'll save that. And then we'll make sure that we have that all set up to go. And we're missing a 14 as well. So it's kind of a lot of trial and error here, but really there should only be, there's a finite amount of these. Basically, there's one unique number between 0 and 15. That's all the possibilities there could be. So right now we've got 0, 1, 2, 3, 4, 5, 6. So we're missing a 7. And then, of course, the 14 that we just encountered. So maybe we can preempt that with putting a 7 in there too. So we'll need to make a 14 and a 7. Okay, let's do it. Stop this. And so 14 is going to be a 12 plus a 2, probably. So we'll open up the 12, and we'll save it as a 14, 14A. And then a 2 would be the easternmost exit. So we'll just go in here and create that. Save that as 14. Otherwise looks good. And then we'll open up. See, we also need a 7. 7 would be a 6 plus a 1. So we'll come in here, save this as 7A, and then just knock out a north exit up at the top. A lot of SpriteTile work today. I hope that it's interesting. I like making maps, so hopefully you like watching maps be made. There we go. Let's just make sure. I have a feeling maybe I didn't make the top of the 14 correctly. No. Was it the 11? No, looks good. Okay. We can always catch that again later. So now we should have everything. Let's see. Looks pretty good. I'm not seeing any errors, at least. So let's see if we can find any rooms that have 3 exits. I'm assuming there must be at least one somewhere. Hopefully. There it is here, this one right here. So you can see this guy. Not sure exactly where the orphan was. It looks like the orphan was probably right down here, maybe? I don't know. Anywho, that's it's working out pretty well. You can see that all of our map grids are filled in. We're not having those weird gray unfilled rooms anymore, which is kind of cool. So basically a lot of content work needs to go into a system like this, from this point. We kind of set it up where we've got this extensible template system where we could go in and we have a couple axes to work with here. One is that we could create really any number of room templates that we wanted for each kind of variation. So like, for example, let's find like the 14. What we could do here is we could save this as 14B. And what we could do is we could have more of a like weird shape to this room. For example. Oops, wrong corner. Maybe we'll make those a little thicker. These areas, like a 2-tile wide walkway. It's a little more interesting. Yep. So what we can do is just go in here. Put these walls down. Oops. That was not the right piece of wall. Easy to correct though. Okay, I think that looks like it should. So this is just a little bit of a more interesting room because it's, not just a complete square. We also do have to change the trigger because we don't want it to overlay those weird room inserts on this particular map. So on this map, we would probably just put some lights in those corners specifically. And then what we can do is, so we can say 14 has an A and a B now. And then we'll go back into our code here, and we'll just hard code the exits to 14 just so we can kind of make sure that's working or looking how we want. So you can see, like, here's a 14, that's the square. Here's another 14, it's a square. And here's a 14 that is the, kind of weird pattern. It's exactly the same idea. It's got an exit on the left and the right and the bottom. But it's not just a square room. It's got a little bit more interesting hallways to it. So we could do any number of those kinds of changes and add those templates into the mix to kind of keep the room geometry looking a little more interesting. And ideally, we'd have a lot of these template variations so that, there aren't just these big square rooms everywhere. It kind of feels more like a series of sometimes larger rooms, sometimes hallways, sometimes odd-shaped rooms, and then a lot of variation in the middle. So that was one way to scale it, was with the room templates themselves, and then the other way to scale it is with those interiors, like these guys right here. So we could create any number of these guys that could go in the middle of the big rooms. And my plan at the moment is to perhaps have several different sizes of these. So this one I called L1 through 6, because it's large. Large being the maximum size for the room. But there's, theoretically we could, let's say we had a smaller room, like, maybe not that guy. Let's see, maybe C, 15C, yeah, like this guy. Oops, I placed a thing there. Maybe we could have a little insert that goes in here, a little randomized insert that's maybe like, 1, 2, 3, 4, 5, 6, 7 by 5 or so. And it would just fit right in here in this little area perhaps. And so we could call that like small 1, small 2. Maybe it could be like this. And then you could have lights in the corners or whatever, what have you. And lights aren't the only thing that we can hint on these maps. Obviously, we can use these triggers to add a whole bunch of other stuff to the maps. Lights, places to put monsters, places to put treasure, places to put warp zones, decorations like houseplants or bookshelves, that kind of thing. The next steps with this stuff, so we've kind of worked on the generation a little bit. I think that some of the next steps for this particular feature would be to, one, kind of mark some of these rooms with some more metadata. So one thing I want to do, when I created this map room class, I gave it this distance property, and the distance property is going to tell me how far from the start, quote unquote start room, each room exists. And so that's a piece of metadata that we can use to make the rooms more difficult as you get farther away from the start. It's where or how we can choose, where the exit to a level should be. We can say that the exit should be at the furthest dead end from the center, so that we guarantee that we don't get any weird levels where like the exit is just 4 rooms away from the start or something. The other thing that I want to do is I want to have like a kind of like a, not necessarily keys and doors literally, but a key and door system where perhaps there are blocks that you need to click buttons to open. Maybe there's like 2 buttons per door or something. Lots of stuff we could do there. But the idea would be that we could attach metadata as we're traversing the map to let the generator know that, like, hey, this is a place where you could put a wall. And then what we'll probably do in that case is that for each of these room templates, we would come in here and we would like have some kind of a, who knows, by that time we might be up to like 10 or something, and we would have like a 10 here in each of these corners maybe, or each of the exits. And then this is where the generator would put like a obstacle that would need to be either opened with a button or opened with a key, or however we end up approaching that kind of like key and door system. But essentially just a gate, just a gateway, so that, you know, we can force you to go around the map to discover where the buttons or the keys or whatever happen to be. So maybe we'll work more on that next time. I think we're just about out of time for this stream. Let's check in with chat. And if anyone has any questions, feel free to just let me know in chat. I'll hang out for a couple more minutes, and then we will end the stream. And of course, if you like it, please tune in next week at 11:30 a.m. PST every week, hopefully. Follow us on Twitch, twitch.tv/LostDecadeGames. You can also follow us on Twitter, twitter.com/LostDecadeGames. And if you like the looks of this game, this is basically all the assets and a lot of the ideas from our game on Steam. It's called A Wizard's Lizard. You can check it out at wizardslizard.com. You can get it on Humble or Steam, anything like that. Is the game done yet? Yes. As you can tell, it's really fun. The game is called Make Maps in SpriteTile, and I'm getting very good at it. We also have a weekly podcast, if you're into that sort of a thing. You can listen to Matt and I chit-chat about game dev, tech, business, design, random everything related to games sometimes. We tend to ramble, but it's a good time, I think. Well, looks like there aren't a whole lot of questions, so I'm going to go ahead and end it here, and I want to thank everyone for coming by, and join us again next week for another Game Dev live stream. Thanks a lot.